So attribution is one of the hardest concepts in marketing. Really, the customer comes in and they do see 5 different ads from 5 different channels, and nobody knows what channel or ad that we want to credit for the conversion. Or people have different ideas. So the marketing team is like, okay, we're going to use first touch attribution. So we're going to credit the first channel or first ad the user goes through. And then the sales team is like, no, we made a call towards the end. We closed the deals. We ended up running an email campaign at the end. There was a buy now button there, and that's how we converted. So it's a counterfactual problem. Customer comes in, they go through one ad, they go through another ad in a different channel, they convert. So the question is, what if, like, they didn't see the first ad, they just saw the second ad? Would they convert? Or they didn't see any of the ads, would they convert? Right. So these are very much not a process or approach problem, but it's actually identifying what question we're trying to solve problem. So there's already available models out there out of the box in Adobe and different analytics, Google Analytics, and there's multiple different new third-party analytics platforms out there. But they give you one of the ways you can solve this problem and say, okay, we're going to create a policy. We're going to say, as a marketing team, when the user hits we let them know who we are as a product. We're going to say we're going to give all the credit to them. Otherwise, without that first touch, they wouldn't know who we are. That makes that assumption, right? And then the sales team says, okay, we're going to go through, we're going to credit the last touch, and say, if we didn't have that buy now button on that last ad, we wouldn't have converted it, right? And then there's different approaches where we can get we can distribute the credit between different channels and between different ads if we want to. And then from there's different ways, like data-driven attribution approaches. For example, Markov chain will say, okay, there's a sequence of things between the customer journey, and we look at the conversion in between these steps in the journey. What happens if we remove one of them? Is the conversion rate changes. Which channel changes the conversion rate dramatically? We're going to credit that channel or that ad. Similarly, there's a shape the value intuition data-driven attribution model where we say, okay, here's a subset of this channel, and we're going to estimate the conversion rate on that channel, and we're going to say the entire channel, the entire ad has the same conversion rate. So, for example, Google Analytics attribution model works this way. But I think the best way to solve that counterfactual problem is experimentation, right? So you want to find the causal inference, and you want to, find the incrementality. You can approach in a different experiments. Basically, you have a control set, treatment set. You randomly select in both groups. You apply the same treatment for both, and you look at the absolute left and relative left and figure out which ad and which house you want to give credit. So let's go through the case study. We put this together with a pharma client a while back. They're going to DTC. They have a product that helps with migraines, and their program is asking people to sign up or enroll for the savings card. They're running an 8-week campaign. They have $500,000 budget in total, and they allocated $200,000 for the meta ads that they have. And they have different channels like Meta, Google, and all that good stuff. And then they get the reporting at the end, and they see the Meta dashboard is telling them your cost per acquisition, your CPA is $48. Initially, they're saying, well, we allocated $80, right? So we're doing great. why don't we double up the budget? Or why don't we serve more ads, right? And one of the finance team guys say, hey, Meta is driving this incremental saving cost enrollments, but are the campaigns driving all of them? What if there was no campaign? Or what if these users are not served with these ads? Would they still enroll, go to the website and enroll from word to mouth, or they know directly? So in order to find that, you want to find that because you don't want to waste money, right, on ads that's going to happen anyway. So what we do is we basically figure out what the discrepancy is by looking at different data points. We run an experiment, and then we run another experiment in a different way just to validate it. And then we decide, okay, this is what we need to do, right? So we look at the Meta dashboard. We see, the dashboard is telling us there's 4,200 signups for the savings card enrollment. And then we look at the CRM, which is basically goes with each entry sign up based on an email, user's name and last name. And then we see there's a huge discrepancy, right? 4,200 versus 2,100. There might be many reasons for this, right? It might be accurate for a different question, Meta's dashboard. But we're looking for conversion to actual signups, right? Is Meta driving all these signups, or is something else is driving it, or nothing else is driving? They already know they're going to sign up, right? These users. So it can be Meta is crediting the signups when people see the ad rather than actually click and sign up, or they might click on the ad and they might land on the landing page, but they won't actually complete the form, or they start from their phone and then they end up not finishing the form sign up, and they go to their desktop and they finish it from their desktop, and Meta sees as two different. So there's a cross-device matching problem. It can be anything, right? What we want to do is, okay, let's experiment. Let's randomly select 25%. So this is Meta does this randomly. They hold 25% of the targeted audience, and they don't serve any ads, and they serve the other 75%. And then the difference is going to give us the absolute lift and the relative lift. So let's do that experiment. We have 800,000 users that we're targeting in our audience. We split it in 75-25, 600K to 200K. Hold out. What we're doing is we have a target audience. We randomly selecting control and treatment groups. That 75 to 25%, and we're running it for 4 weeks. Our primary metric is the savings card enrollment per user. So we already have predetermined minimal detectable effects outlined. So we have 50% relative is what we're expecting. We want 80% probability, our power, and then we want p-value to be lower than 0.05. So all standard stuff. And just since we assigned 600, right? This is 25-75 split, just to make sure that's enough sample size. We calculate the sample size. It's more than enough. We get to 440. So we run the experiment, and then we see that the tests, the treatment group, right? The audience that received the ad conversion rate is 1.90, and the holdout group conversion rate is 0.16, right? 16. So we do see this conversion even if they don't see the ad, right? So then we calculate the cost per acquisition, $158, and we see 1,200 people signed up with Meta's ad. So we have about 800 people that are actually, they were going to sign up anyway. They didn't see the ad and they still signed up, right? So, or it might be a different channel. So we can't attribute that to Meta, right? So we can't combine that to Meta's ad. So that changes our plan, right? So if we said, okay, it was $48 CPA, now it's $158 CPA. So what are we going to do? Let's validate this because we only ran one experiment. Let's go here and we run, basically just to validate, we run this with different geographical regions. So it's a different experiment we're running just to see if it's within the same range that we're going to get the results from. We run in California and where we feed the ads, or and then in a different region we turned it off, and then we calculate the diff and diff cause and effect, and then we want to see if it's going to be around the same number of effect that we get from Meta in this experiment. So you can see, and during the test period, we have 1,890 people and enrolled, but we have 580. We have 510 on the still enrolled without serving them any ads. Then actual enrollments from the Meta ads is 1,307. We ran two different methods in terms of experiment, and they are pretty close. 1,266 versus 1,307. That's within the 3% range, so we can validate that our experiment is correct. The actual CPA is $158. The number of people that signed up is through the Meta ads. The effect of Meta ads is 1,266. And then what do we do now with that, right? So we look at it together. We say, okay, hey guys, we're not going to double our budget. We're not going to serve more ads. CPA is not 48. We see on the server side, it's 95. And we did an experiment. We did a conversion lift study. It's actually a lot of people, even if they don't see the ad, they're going to sign up. So we don't want to waste our money budget with that. We can rescope the ads, or we can simply rescope the ads, and then we apply the same to the other channel, other ads that we are running within the campaign. So we can perform this case by case basis, right? So we wait for the data, and we do the experiments, and we, in a periodic way, we adjust the budget's allocations for each channel, each ad, and make the budget allocation for the campaigns a lot more accurate, and we're not wasting any money. But we can also productionalize this, meaning that's something that we do with an Agent 917. We create a pipeline where we streamline this process, where we can actually run the experiments while the actual ad is going. So small, medium-sized businesses can benefit from it, or enterprise business can benefit from it on a very immediate way.